I am Rajin Mehta here. I have completed my masters way back in 2000, and since the last 17 years I've been accumulating a lot of experience in the field of power quality, electrical network assessments, audits, power conditioning systems manufacturing, a whole wide of experience in the entire electromagnetic domain. Prima facie, I did about more than 200 different audits all over the country and even abroad in the fields of network improvement studies, power system studies, energy efficiency studies, power quality audits, harmonic studies, and was also instrumental in setting up an entire production line for power conditioning systems, including reactive power compensation systems, harmonic filters, transformers, isolation transformers, and even set up one of the India's first full load reactive power and harmonic filter test benches, up to nearly 500 kW in my earlier capacity as technical director of Power Matrix Solutions Private Limited. Currently I am working in Apqi Energy Consulting Private Limited and trying to build a scalable platform to help customers enhance their reliability, efficiency, safety and compliance in their entire electrical network domain. So that's the purpose with which we have started this company. Firstly, power quality. This case study is obviously about communication industry, but now with the cross breeding, if I would say, if the term cross breeding or cross fertilization of different technologies across different industry domains, more or less the issues in power quality have become common across a lot of such industries where there are a lot of sensitive equipments. So what is important in these kind of industries, first is the nature of the equipments that are being used. If you understand, these equipments have, especially in communication when I'm speaking about, a lot of different kind of signals in the electromagnetic domain, if I would say. You have your power quality signals, you would have your noise signals in the video data, AV signal that you would call it, you would have the grounding signals. So from a power quality troubleshooter's standpoint, if I would say, if you are faced with an issue which is causing a problem or a malfunction in a sensitive equipment, it's really a big nightmare, because you are transcending across different type of signals which are very complex, very miniaturized at the same time. So for example, if you take the case of a microprocessor sitting on the output of a small DC supply on a PCB, you're talking about the tolerances of 3 to 4 volts as the difference between the state 0 and 1, and a smallest of interference which can get coupled through the capacitor grounding, for example, or through the output DC supply because of an isolated impedance of the wires that the capacitances on the PCB offer at very high frequencies. These can cause really a lot of trouble in terms of the functioning of these miniature equipments. Not miniature equipments per se, but the miniaturized nature of the signals can cause malfunctions which are very, very hard to decipher and correlate as to what's going on and what is the actual cause, because the equipments themselves, they do not shout out about the tolerances that they are they're allowed to operate in. It's a very gray line which these equipments, for example a drive or rectifier or even a UPS for that matter, or a rack, a server rack, which they can tolerate. So that makes it all the more challenging. And at the same time, what our experience is, along with these tolerances, there are a lot of coupling channels which come into play that make the power quality available to any piece of equipment to be worsened further. The coupling channel can be in the form of improper grounding in the system. It can be in the form of, as I said earlier, a capacitor sitting on a PCB which has been grounded to the body of the equipment, and the body is picking up the signals from some other noise generating source, and it is being transferred. Or it can be an improperly installed power conditioning system. So a lot of these things aid the worsening of the signals that these sensitive equipments are being subject to, and thus result in malfunctions or failures. So in this specific case study, that we did and have put a case study on APQI, what were the specific issues observed, if you ask? First and foremost, there were leakage potentials in the ground system. Secondly, there were moderate to high dV by dt fluctuations which were observed, coupled with sags and swells at different times, different points in time. At the same time, the overall facility was capacitive in nature due to the fixed capacitors which were installed to maintain a high power factor to obtain incentives from the utility company. So what was the cause and the effect overall? After a study of nearly 20 to 25 days that we did, the main cause which we zeroed in was external to the facility, which mind you is not normally the case. 70% of the issues that we normally find are within the facility, but in this case the major cause was outside, if we would tell. It was HT capacitor switching on the utility side, which generated these high dV by dt fluctuations. But as I mentioned earlier, there were a lot of coupling channels which were existent inside the system. One of them was a weak star point grounding, which was in the transformer of the customer in question. The loads in question, the effect was on the rectifier modules which used to fail. Because of this HT capacitor switching that used to generate high dV by dt fluctuations, and these rectifier modules used to fail. So that was the effect. The effect was exacerbated because of the fact that the loads were connected in a 3-phase and a PE configuration. They didn't have a neutral, it was a 3-phase and a potential earth configuration. So in effect what happened is, because of the weak source star point grounding, that coupled with an ineffective TVSS, your normal TVSS, if you call it, the transient volt surge suppressor, it was ineffective in clamping the transients that were coming from the utility side, because the configuration was not right. It was not in a grounding clamp down configuration. So it used to pass on these transients, and that coupled with the weak earth network in the system used to go and affect the rectifier modules through the PE terminal of the rectifiers. So that was the cause and effect. As far as monetary losses were concerned, they were really huge. In a matter of few weeks, there were like 3 or 4 rectifier modules which failed, and these had to be chartered, shipped from probably US, if I remember it right, to get it replaced, because it was a really critical 99.999% uptime facility as a requirement. So it approximately 2.5 million rupees was the cost that the customer had to face in a matter of few weeks, when the facility had been running for nearly 6 to 7 years trouble free without any issues. So as far as mitigation is concerned, to ensure that we solve this problem that the customer was facing, there were multiple approaches. The first approach always that we take is a low cost, high bang kind of approach, which can try to solve 80% of the problem that the customer is facing. So with that in mind, the first and foremost thing was to go and talk to the utility company and request them to switch the capacitors not together. There were 2 stages in the HT capacitors, switches in sequence, which could reduce the intensity of the dV by dt. At the same time, other actions on the customer end were taken was to lower the ground resistivity so as to strengthen the neutral star point grounding. Further actions were to reduce the capacitive nature of the load, make it inductive, so that the magnification of the transients did not happen to that extent. And lastly, we went for installation of class 1, 2 and 3 surge protected devices separated by decoupling inductances, which effectively reduce the intensities drastically of these dV by dt transients that the customer was having, and helped in reducing the issues significantly. Since the last 4 to 5 years, they have had almost no failures at all of these modules. Environments. First and foremost, it's design, design and design. A lot of care should be taken at the design stage to ensure that you are giving a good ecosystem in which these equipments can really work in harmony. First and foremost, it can be like the grounding. Special care has to be put on the grounding requirements for these equipments in terms of the noise buffering and mitigation, because they're very highly sensitive, as we already spoke earlier. In terms of the general installation practices recommended by the OEMs of these equipments, they need to be adhered to very strictly, on not left to the contractors who are doing the installation in a standard way, the way in which you would install a motor. You cannot have the same principles applied to a sensitive equipment like these. Second, once you are running the facility, a routine and a periodic audit of the entire system, subsystems that go into forming the entire environment in which these systems are installed. It's akin to a BP or a cholesterol check, which you can do, but it can give you good indicators of the health and predictive maintenance or predictive actions which can be taken to proactively prevent such risk from such downtime from happening. And lastly, don't look at short-term savings is our experience. For example, copper terminations versus aluminum, they go a long way in ensuring that the life over the entire life, maybe 10-15 years, you would not expect any significant issues because of short-term savings being done at the design stage, as opposed to the life cycle cost savings that would accrue because of such initial investment, which seem to be higher but offer a much longer ROI, a much higher ROI in the long term. So my experiences and views about the contribution of Asia Power Quality Initiative APQI in this development of the PQ ecosystem in India, I would very honestly say that it's a phenomenal platform from my association with it since the last 3 to 4 years, very hands-on. Why I say that is because I've not seen a platform which delves into so many different forums or so many different areas to disperse knowledge in an absolutely neutral and absolutely knowledge sharing kind of perspective. For example, we have on the APQI website, which is supported by International Copper Association, there are so many different case studies, so many webinars, so many discourses, so many blogs which routinely come up, and so many networking opportunities through the different events in the physical space that APQI organizes. That I feel tomorrow, when reliability is going to become the new availability, once our goal of our present government to have 100% electrification is achieved, power quality is going to take mainstream attention, and at that point APQI is poised very well to take advantage of this fundamental, the strong foundation which it has built, and drive a lot of discourse and rhetoric on power quality awareness in the country. At the same time, very important, the value systems of the people that drive this platform also play a very significant role, and I'm really happy to share that I have not found people with such a passion to drive the purpose and mission of this platform and take it to its logical future. So I wish them all the best, and I hope to contribute as an NSN partner to APQI in the years to come. Thank you. Jai Hind.